So how's everybody doing out there? Well, welcome to day 20 of Corona Online School. So today we're moving into the arithmetic section of fractions. So I know this is everybody's favorite part. So we're going to have this broken up into like denominators, which if you remember anything about adding and subtracting fractions is the much easier situation to be in, and unlike denominators. And we're going to be looking at different models and how to do these, and then there's a bunch of practice ones for you guys to work on. So let's jump in right away and start looking at these. So if we look at example 1, so the goal is we want to use models to add 1 1/5 plus 3/5. And so if you notice, I've got two rectangles drawn out, so I'm using my kind of area model for this. And so the first thing it says is divide each rectangle into 5 pieces, which is a good start since our denominator for both of these is 5. So that means I need 4 lines to do this. So I'll get 1, 2, 3, 4. 1, 2, 3, 4. And so then how many 1/5 pieces do I have to shade to show 1 1/5? So remember, the whole number 1 means that we're going to shade everything in this case. So I'll use blue to represent 1 1/5. So that means we need 1 whole, which is going to be this whole entire rectangle. So that's the whole number 1 part, and then we need 1/5, which is just going to be one of these little blocks in this case. And then how many do we need? Did we actually shade in this case? So 1, 2, 3, 4, 5, 6. So we shaded 6 blocks. So 6 1/5 pieces. And so now the same thing for part C. How many 1/5 pieces do we shade to show 3/5? So in this case, we can answer right away. We know it's just going to be 3. And so let me get a different color here. So let's do 3/5 in orange. So that means we want to shade 3 of these 1/5 chunks. So we've got 3 of those guys. So 1, 2, 3. So that's going to represent our 3/5. And so finally, how many 1/5 pieces do we have all together? So we want to add all the blue and all the orange together. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 1/5 pieces all together. So name the improper fraction that's now shaded. So in this case, the 9 is just going to be the top number for our improper fraction. And our 5 is still our denominator since everything's broken up into 5th chunks. And then name the mixed number that's shaded. So again, with the mixed number, we're just looking to see how many holes there are. So in this case, there's just 1 whole. And then there's part of a hole over here. So that means our big number is going to be the 1. And then how many little parts do we have? We've got 1, 2, 3, 4. So that gives us a 4 for the top number. And again, 5 for our denominator. So finally, what's our answer here? 1 1/5 plus 3/5 would be 1 4/5 or 9/5 in this case. So that's what it looks like to add using a model. So again, we're just kind of, since everything's a like denominator, just kind of makes things easy. Shade in all the regions from both numbers and then just add up the total regions that are shaded, and that'll give us our nice answer. The denominator is going to stay exactly the same because the chunks didn't change or anything like that. So, all right, very good, very good. All right, so let's look at example 2, which is adding 2 fractions with the same denominator, but this time using a number line. So first thing we're going to do is we want to put 1 5/8 on a properly marked and labeled number line. So in this case, just to make sure I give myself enough room before I actually start dividing it up, I'm going to kind of set this up as a... So I'm going to go out to basically 3 just to make sure I have enough room, hopefully, for this thing. And then now the key is, since both denominators are 8s, I need to break up each of these individuals, between 0 and 1, 1 and 2 and 3 into a bunch of 1/8 chunks. So I'm going to need 7 lines in each section. And again, try to make them as even as possible. So 1, 2, 3, 4, 5, 6, 7. That wasn't very even, but 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So not terrible. Some of them aren't very good, but we'll take it. And so the first thing we want to do is actually make our first jump by going from 0 up to 1 5/8 in this case. So again, our 1 tells us that we're going to basically start there, and then the 5/8 tells us we want to count over 5 tick marks from that 1. So in this case, we've got 1/8, 2/8, 3/8, oops, 4/8, 5/8. So this is where we want to land with our first jump. So let's start at 0 and jump there. So that's our 1 5/8 jump. And so now what we want to do is jump a 7/8 jump in this case. So again, starting where we left off with the 1 5/8. So let me use a different color. Let's use this pink. So now, since we want to jump 7/8, the only number that really matters here in this case is the 7. Because since we've broken this up into tick marks of 8, what we really are jumping is 7 of these 1/8 tick marks. So in this case, we want to jump, 1, 2, 3, 4, 5, 6, 7. So we want to land there. So in this case, this is going to be our 7/8 jump. And then ultimately, the addition of these is just one big, in this case, 1 5/8 plus 7/8. So where did we actually end up? So we've got the whole number 2, so we know it's going to be 2 and something. So now we just have to count over how many tick marks to get the fraction part. So we've got 1/8, 2/8, 3/8, 4/8. So where did we land? We landed at 2 and 4/8, or in this case, since 4/8 isn't simplified, we'd want to do like we did in the last section and kind of divide each of the tops and the bottoms until we can get it in reduced form. So in this case, hopefully notice that I can divide a 4 into the top and I can divide a 4 into the bottom, and that's going to give me 2 1/2 in this case. So 1 5/8 plus 7/8 is going to be the same thing as 2 1/2. So again, that's kind of how we're going to do number lines, especially when they're like denominators. So because again, the nice thing is once we divide those tick marks up, then we just have to focus on the top numbers and make sure we're moving the proper number of jumps with the top numbers in this case. All right, is that okay with everybody? All right, hearing nothing. So in this case, let's look at subtracting things with like denominators. So again, we've got the same kind of idea. I've got my 2 squares laid out. And so we want to use the area model to subtract 1 1/5 minus 3/5. So again, first thing we want to do is divide the rectangle into 5 equal pieces, because again, our denominators for both of these guys are 5. So that means we need 4 lines to do this. So we're going to get 1, 2, 3, 4. 1, 2, 3, 4. And so again, just like last time, the first thing we want to do is kind of start with the bigger number and shade 1 1/5 and figure out how many pieces we're going to get. And so this is just like last time. So we know we're going to get 6 of them. So let me shade those in like we did last time. So in this case, the blue is going to represent 1 1/5. And so again, just like last time, we had 1, 2, 3, 4, 5. We have 6 chunks. So in that case, that gives us our 1 1/5. But now, what we're going to do is, since we're taking away, we're subtracting 3/5 instead of shading more in. Now the goal is we want to use our takeaway method and actually get rid of stuff, take stuff away. So in this case, how many 1/5 pieces are represented by 3/5? So again, they're just 3. So now the goal is, what we want to do is we want to go through and subtract or take away 3/5 of these guys. So I just chose to take the last 3 away. You could take any of the 3 away. It doesn't matter which 3 you take away. And then what's left over, so in this case you would count, especially if you happen to like take random ones away. So we notice that we've got 3 shaded pieces left. So that means we've got 3/5 left over. So 1 1/5 minus 3/5 would be the same thing as 3/5 with the area model. And so again, subtraction isn't too bad, especially when it's like denominators, because again, everything's already divided up the right way. So we're really just focusing on, instead of the bottom number, we're really just focusing on how many things can I take away from the top number, how many of those 1/5 chunks can I take away. And so this actually works out perfect. All right, is that okay with everybody? All right, good job. So let's look at using the number line to subtract like denominators in this case. So again, this is going to be similar to what we did before. So again, the first thing we need to do is we need to label the number line and get it in terms of the right tick marks. So since this one's a subtraction, I can give myself a little bit more room. So instead of going out to 3, I'm just going to go up to 2 in this case. And so again, before we try to label anything, next thing we want to do is we want to divide this up into the like denominator. So in this case, our denominator is 8. So that means we need to have 7 tick marks in here. So we get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so again, we want to plot the bigger number first at 1 5/8. So in this case, we'd start with 1 and then count over 5 tick marks to get our 5/8. So 1 1/8, 1 2/8, 1 3/8, 1 4/8, 1 5/8. So there's where we want to land. So now we want to do a big arc that goes from here to here. And so now what we're trying to do, and again, if you want, you can treat this like we did when we were doing the integers, for example. Instead of thinking of this as a subtraction problem, you could think of this as a missing add-in problem. Because again, this is the same thing as saying, what would I add to 7/8 to equal 1 5/8 in this case. So again, we can think of this as kind of a missing add-in problem. So the goal is, now I want to draw my 7/8 so I can figure out what I would need to add to it. So let me get the pink going. And so again, since we've got the same denominators, I don't really have to worry about the 8. I really just have to focus on the 7 and move backwards 7 tick marks from this current position. So in this case, I've got 1, 2, 3, 4, 5, 6, 7. So that means, from a missing add-in perspective, this would be my 7/8 in this case. And so the subtraction, let me do it in a different color, is actually going to be whatever this jump is. So 1 5/8 minus 7/8 is going to be wherever we land right there. And so since it's to the left of 1, that means it's going to be not a whole number or not a mixed number. So we can just count. We've got 1/8, 2/8, 3/8, 4/8, 5/8. So it looks like we're landing at 6/8 for our subtraction in this case, or 6/8 plus 7/8 would give me 1 5/8. So again, there's a couple different ways you can think about these subtraction problems. So where did we land? We landed at 6/8. And so again, hopefully you recognize this isn't in simplified form. So the first thing we should do is simplify it. So in this case, I can divide a 2 from the top and a 2 from the bottom. And that gives me a 3/4, which is simplified. So this is good. And so my final answer, 1 5/8 minus 7/8, would just be 3/4 in this case. All right. Is that okay, everybody, with adding and subtracting with models of like denominators? All right, perfect. So at this point, I've got some practice problems for you to work on. So practice 1 and practice 2 got at words, 2 story problems that sound similar, but one of them's an actual story problem and one of them isn't. So the goal is I want you to figure out which one is and why the other one isn't, just so you can kind of see the difference and recognize. So when you're writing your own story problems, you don't make this kind of mistake and things like that. And then practice 3 has you practicing some story problems with like denominators. Same with practice 4, practice 5, practice 6. And then when you're done that, come on back and then we'll talk about addition and subtraction of fractions with unlike denominators in this case. So at this point, practice these problems and then come back and be ready for the next video.